How do the sizes of atoms change as we move A from left to right across a row in the periodic table? A row in the periodic table is called a period. So if we go across the second period, the second energy level, I add more and more protons to the nucleus, and that decreases the size of the cloud. It makes it tighter and tighter as you go across. As you go down a group, you're adding an energy level. So if I go down group 1A, I add a third, a fourth, a fifth, a sixth energy level, and the atom size gets bigger, as shown by this graphic, right? So lithium, if you're going across the second period, lithium is the puffiest atom, and the cloud gets tighter and tighter and tighter as I go across towards fluorine. Sodium is the puffiest in the third period, and as I go across, it gets tighter and tighter as I go towards chlorine. C, arrange the following atoms in order of increasing atomic radius. All right, so oxygen is shifted over to the right, and it's highest up in a group, so it's going to be smaller than silicon, which is going to be smaller than germanium because it's farther up in a group, more towards the top in a group. Iodine is going to be the biggest because as you go down a group, even though it's shifted more across in the period, as you go down a group, you get a more dramatic increase in size because you're adding an energy level. So increasing, going from oxygen over to iodine. True or false? Cations are larger than their corresponding neutral atoms. Well, that's false. As you lose electrons, you get less electron-electron repulsion, and therefore the cloud gets tighter. Most atoms lose their outer layer until we get down to the core electrons, which would be the case with lithium. Lithium loses its outer electron to become lithium plus, and lithium plus is much smaller than lithium. So you've got a shielded 2s electron being taken to form a lithium plus. Chloride is bigger than iodide. Chloride is bigger than iodide? No, it's going to be smaller. Chloride has, let me get that up there. Chloride has way less inner electrons blocking the outer electrons from filling the nucleus. So when I get to chloride, it's much smaller than iodide. So a neon core as opposed to an argon core blocking the outer electrons. What is an isoelectronic series? An isoelectronic series is when a group of ions and atoms have the same electron configuration. Which neutral atom is isoelectronic with each of the following ions? Okay. So if we're looking at gallium 3+, right, that's gallium losing 3 electrons. You'd lose 1 electron out of the 4p and then 2 electrons out of the 4s, and you'd have an argon configuration. If you've got zirconium 4+, you're losing 2 electrons out of the 4d and 2 electrons out of the 5s, and that would give you a krypton configuration. If you're looking at manganese 7+, you're losing 1, 2, 3, 4, 5 electrons out of the 3d and 2 electrons out of the 4s to give you an argon configuration. And iodide, you'd be gaining an electron and have a darn it, I forgot it. What is it? Krypton, xenon electron configuration. Had a mind block there. Lead. All right, so if you're lead 2+, you're losing electrons out of the 6p, and that's not going to be isoelectronic with anything. You'll have 10 electrons in the 3d, 4d, the 5d. So you're not going to be electronic with isoelectronic with a neutral atom. For each of the following sets of atoms and ions, arrange the members in order of increasing size. All right, so selenium gaining 2 electrons. The anion would be bigger than the neutral atom. And Trillium 2 plus would be bigger than selenium. I'm sorry. Trillium 2 minus would be bigger than selenium 2 minus. So Trillium 2 minus has a xenon configuration. Selenium 2 minus has a krypton configuration. Both of those are bigger than selenium. Cobalt 3 plus would be smaller than iron 3 plus because it has more protons pulling in the nucleus, and both of those would be smaller than iron 2 plus. Which has more electron-electron repulsion. If we're looking at calcium, calcium can lose 2 electrons. Calcium metal versus Trillium metal. All right, so Trillium 4 plus would be much smaller than calcium 2 plus, and that would be smaller than scandium 3 plus. So calcium would be the biggest, Trillium 4 plus would be the smallest. Beryllium 2 plus and sodium plus. Sodium plus would be a neon configuration. It'd be smaller than neon, and beryllium would be beryllium 2 plus would be a helium electron configuration, a helium core. So that'd be smaller than both of those. Identify each of the following statements as true or false. If false, rewrite it so that it's true. Ionization energies are always negative quantities. Nope, they're positive. It's an endothermic process. You got to put energy in to knock an electron off. B, oxygen has a larger first ionization than fluorine. Nope, they're both in the same group. And fluorine has more effective nuclear charge holding onto its outer electron than oxygen does. C, the second ionization energy of an atom is always greater than the first. True. You get less electron repulsion as you take electrons out of a cloud, and it gets harder and harder to take electrons out. Why does lithium have a larger first ionization energy than sodium? Answer, less shielding. You're dealing with a helium core with lithium as opposed to sodium where you have a neon core. So 2 inner electrons blocking the outer electron with lithium. So you're going to have a higher ionization energy, first ionization energy with lithium as opposed to sodium, which would be a lower first ionization energy. More inner electrons blocking the outer one from feeling the nucleus. B, the difference between the third and fourth ionizations of scandium is much larger than the difference between the fourth ionization energies of titanium. Why? Answer is you're starting to remove core electrons with scandium, whereas with titanium you have a fourth outer electron to take before you start digging into core electrons. So both have a argon core, but with scandium you remove the 4s electrons first, and then you dig that electron out of the 3d, and the next electron would have to start coming out of that argon core, which is much less shielded and a much higher ionization energy. Did I miss something? Let's see. Oh, why does lithium have a much larger second ionization energy than beryllium? Why is that much? Oh, because again, you're removing core electrons, right? So you have one outer electron to remove from lithium. That next electron would have to come out of the helium core, which would cost you a lot of energy. These would be unshielded electrons. Based on their positions on the periodic table, predict which atom of the following pairs will have the smaller first ionization energy. All right, so if we're comparing chlorine to argon, chlorine is going to have a smaller first ionization energy than argon. You've got 18 protons pulling as opposed to 17. So argon would have a higher first ionization energy. Calcium versus beryllium. Calcium, you're taking electrons out of the 4s, which are much more shielded than beryllium. So calcium would have the smaller first ionization energy. Potassium versus cobalt, same energy level, right? That fourth energy level. You've got 27 protons holding on to the electrons as opposed to 19. So a much smaller first ionization energy with potassium. Sulfur versus germanium. Germanium has both things working. No, I'm sorry. Sulfur has both things working for it. It's shifted further over in a period, so more proton pull, and it's less shielded. Argon core, a neon core as opposed to an argon core. So germanium would have the larger first ionization energy. Tin, Sn. Where are you? Tin and Te. Oh, there it is. Sn and Te. All right, so same amount of shielding, more protons with beryllium. So tin would have the smaller first ionization energy. Right, the electron configurations for the following ions, right? So if you're talking about iron 2 plus, you're taking electrons out of the 4s. So that would be losing electrons out of the 4s, you'd have an argon core 3d6. If you're talking about mercury 2 plus, again, you're losing electrons out of the 6s. And so you'd have 5d10 left in that fifth energy level. If you're looking at manganese 2 plus, again, you'd see the pattern. We're taking electrons out of the s that's above the inside D. So the 4s electrons are the valence electrons for manganese, so they're lost first to make manganese 2 plus. If we're looking at palladium, we're taking electrons away from the 6s before we start digging electrons out of the 5d. And if we're looking at phosphide, we're adding electrons to the 3p. So that would be a phosphide would have the same electron configuration as argon. Predict whether each of the following oxides is ionic or molecular. Well, that's going to be easy, right? If you got metal in the formula, you're ionic. If you have both, if you don't have any metals in the formula, you're molecular. So we've done that for a long time now, right? So we consider it a transfer when you have a metal with the nonmetal, sharing between two nonmetals. What is meant by the terms acidic oxide and basic oxide? Acidic oxides are oxides that form acidic solutions when you put them into solution. Basic oxides make basic solutions when you put them into solution. B. How can we predict whether an oxide will be acidic or basic based on its composition? All right, so oxides of nonmetals are acidic. So if I bubble sulfur trioxide gas into water, I'll make sulfuric acid. Metal oxides make hydroxides, right? So if I put an oxide, really barium is just a cation that accompanies oxide. Oxides is a stronger base than hydroxide, so you'll take an H off of that water to make two hydroxides. So non-metal oxides make acids, metal oxides make hydroxides. Why is calcium generally more reactive than magnesium? It's a question of shielding. Calcium has got an argon core, magnesium has a neon core. So it's easier to take an electron away from calcium than it is magnesium. I think I have there we are. Right, there's the core, right? So calcium, more shielding. Why is calcium generally less reactive than potassium? More more effective nuclear charge. You have 28 protons in the nucleus with calcium than you do 19 protons with potassium. So it's harder to take an electron away from calcium than it is potassium. Right, the balanced equation for a reaction occurs in each of the following cases. Potassium burns in an atmosphere of chlorine gas. All right, so redox reaction, right? Two elements coming together to form potassium chloride. B, strontium oxide added to water. A metal oxide will make a hydroxide. Fresh lithium metal is exposed to oxygen. Again, this would be a redox reaction, lithium losing electrons to oxygen to make oxide. Sodium metal reacting with molten sulfur. Again, a redox reaction. I mean, this is what metals do, right? They lose electrons to whatever. If they're going to react, they're going to lose electrons. So make sodium sulfide.